A study of 66 dairy cows found that the mean milk yield was 12.5 kilograms per milking with a standard deviation of 4.3. So we were given the information of X bar being 12.5 and S being 4.3 based off a sample of size 66. We're dealing with quantitative data and a single sample, so of interest is the population mean mu. That's our target parameter here. We want a 95% confidence interval for the average milk yield in the population. Okay, so that is what mu is. We have our mean and standard deviation and our sample size, so the only other thing we need for our interval is our t. Notice we can use t-based inference because our conditions are met. Our sample size is greater than or equal to 30, so that checks out. We don't need to worry about the data set looking normal or anything. Only one of those two conditions needed to be met. So to get this t that you're seeing here from StatKey, degrees of freedom will be n minus 1. So 66 minus 1 gives us this value here of 65. So if we go over to StatKey and we put in a value of 65, hit OK, do two-tail, and we have 95% in the middle right now. You can see we get 1.997. Notice with this larger degrees of freedom that the 1.997 is fairly close to the 1.96 that we used when we used the normal distribution. As the degrees of freedom increases, the t looks more like a normal distribution. So the 1.997 comes from that. So what we get in our interval is x bar plus or minus that t times s over square root of n. That will yield 12.5 plus or minus our margin of error of 1.057. So we get an interval from 11.443 to 13.557. It's asking in part B if it's plausible that the mean milk yield in the population is 11. Just looking at our interval, this does not contain 11, so the answer to that is no. And then if the mean and standard deviation were instead based off a larger sample of 660 cows instead of 66, how would our interval change? Well, we've talked about before if we take a bigger sample that it's better and that we get a more accurate interval. Notice if I have a 660 down here instead, what's going to happen is this number is going to get a lot smaller because I'm dividing by a bigger number. So the margin of error will be smaller, and that will make my confidence interval narrower or smaller.